Hello, today we're going to talk about solving compound inequalities. So the word compound usually means something that has more than one part, like a compound word is made up of two words. Compound inequality is the same idea. It's a combination of two inequalities. These can be written two different ways, like we see here with this first one where we have one inequality here, another inequality here, and the word or in between. Sometimes you see the word and there instead. That's one way to write a compound inequality. Another way to write a compound inequality is like we see right here in the second one, where instead of it being separated by the word and or, it's written as one long string. We are able to solve and graph these, and I will show you how to do that momentarily. When you graph them, instead of a regular inequality where it's just one circle with shading either to the left or the right, because we have two inequalities, we're going to have two circles, either open or closed, and then shading either in opposite directions from the circles or in between the two circles. Quickly, before we do any solving here, let's remind ourselves, if we are dealing with a less than or greater than, it's an open circle. But if we're dealing with a less than or equal to or greater than or equal to, it's a closed circle. Also, which direction do we shade? If we are dealing with less than or equal to, we shade to the left. If we are dealing with a greater than or equal to, we shade to the right. We'll kind of come back to all these as we solve these. So to actually solve these, very similar to solving equations, and most of these are not going to take more than one or two steps to solve. If it's written as two separate with a word in between like or, you're going to solve them as two separate, and then we'll talk about the graphing from there. So let's take a look at this first one. I have negative 6 plus x is less than negative 3. To solve that, I need to add 6 to both sides. I get x less than or equal to negative 3 plus 6 is 3. That is done for that part. Or I get what happens when I solve the other one. To solve the other one, it's negative 6x is less than negative 60. I need to divide by negative 6. Since I divide by a negative, I need to flip my inequality. So x stays the same. Negative 60 divided by negative 6 is positive 10. The inequality flips around and turns into greater than. This is the inequality part of my answer, which is good. But now I need to graph this. So first, I like to figure out what kind of circles I'm dealing with. I have an open circle on 3. Since it's a regular greater than, I also have an open circle on 10. And then which way do I need to shade from each circle? I'm going to do just a little bit of shading to see how it should look. I need to go to the left of 3. I need to go to the right of 10. So now it looks like my shading is going to be in opposite directions. When we have an or inequality, the shading will go in two opposite directions. So I'm going to finish that shading off. So this right here is my final answer graph. The values of x that work for this compound inequality are either in the orange part or they're in the blue part. If your inequalities are written as one long string, like we see in the next one, it's like solving an equation where anything you do to one part of the equation, one side of the equation, you do to the other. But since I have 1, 2, 3 parts here, anything I do to one part of the equation, I got to do to all 3 parts. So we're focused on getting k by itself. So let's look at that middle part. How do I get k by itself? I need to undo adding 8 by subtracting 8. But since I'm doing that to the middle, I got to do that to the left and to the right as well. Negative 4 minus 8 is negative 12. Less than or equals 2 stays the same. 6k stays the same. 68 minus 8 is 60. What else do I need to do to get k by itself? Well, I need to divide by 6. Since I'm dividing by 6 in the middle, I should divide by 6 on the left and the right as well. Negative 12 divided by 6 is negative 2. My inequality sign stays the same. K stays the same. Inequality stays the same. 60 divided by 6 is 10. So this, believe it or not, is our answer. See how k is situated in between negative 2 and 10? That means all the values of k that work for this inequality are going to be in between negative 2 and 10. The kind of circle that's going to be on negative 2 is going to be a closed circle because I have a less than or equal to there. And the kind of circle that's going to be on 10 will be an open circle because I don't have an equal to with that inequality. Since k is in between those two numbers, my shading is going to be in between those two numbers. So this is what we would call an and inequality where the shading is in the middle. Let's try a few more. The next couple are written as two separate, so we're going to solve them as two separate. So I'm going to start with this part right here. To get n by itself, I need to add 3 to undo minus 3. I get n less than 2. Pretty short and sweet there. To solve the other one, it's n divided by 10. To undo dividing by 10, I multiply on both sides by 10. I get just n here, greater than or equal to 1 times 10 is 10. Okay, and the word or is in between. So let's do a little graphing here. I have an open circle on 2, and I have a closed circle on 10. It's okay to have one of each, perfectly fine, no problem there. Its n is less than 2, so I'm going to shade a little to the left of 2 to see how it works. N is greater than or equal to 10, so I'm going to shade to the right. My shading is going to be in opposite direction, so I'm just going to finish that shading off. So once again, when we have an or, the shading is going to go in opposite directions. You can think about that because both those words start with O. Next up, this one is also written as two separate pieces, so I'm going to solve it as two separate pieces. To get n by itself, I'm going to divide by 5. 50 divided by 5 is 10. Also for this one, to get n by itself, I need to divide by 6. And the word and is in between those. So I have n is n is less than or equal to 10, and n is greater than or equal to 3. Let's put those circles down. Close circle on 10. Close circle on 3. And then let's do our shading. Less than or equal to 10 means we need to go to the left of 10. Greater than or equal to 3 means we need to go to the right of 3. So my shading is going to be in the middle here. So everything that's in between the two circles works my inequality. And inequalities are in between for the shading. Let's try one last one before we try a word problem. This one again is written as one big long string like we had in that second one. So anything we do to one part of the inequality, we have to do to all three pieces. We are focusing on the middle. What do I need to do to get x by itself? I need to subtract this 2 first. So I get -4, inequality stays the same, 4x stays the same, inequality stays the same, 14 minus 2 is 12. And then last but not least, I need to divide everything by the number in front of x, which is 4. -4 divided by -4, or -4 divided by +4 is 1. 4x divided by 4 is x. 12 divided by 4 is 3. So then to finish this off, we need to make our graph. Both of these have equal to's in it, so it's to be two closed circles. I have a closed circle on -1. I have a closed circle on +3. X is situated in between those two numbers, so my shading is going to be in between those two numbers. When you're doing these on your homework, you can make a simple number line like this that just involves the two numbers you care about. So I'm going to use this last problem as an example. My two numbers are -1 and 3. And put the circles and the shading where they go. You don't need to draw every single number on the number line like on the ones I had provided here. All right, the last thing we're going to do for compound inequalities is solve a word problem. Your bank account begins with $50 and increases by $25 for each deposit you make. Let's kind of put that part into numbers. We start with 50, increases by 25, so plus 25 for each deposit. Do we know how many deposits we're making? Nope. So deposits are x. So part of our inequality is going to be 50 plus 25x. If you would like your bank account to be between $450 and $550, what range of deposits would achieve this goal? So since we want to be in between two numbers, we are going to set it up as one of these long string compound inequalities. With these long string compound inequalities, the smaller number goes on the left and the bigger number goes on the right. So to put this all together, 450 is the smaller number, less than or equal to, or sorry, it's just going to be regular less than. Between doesn't actually include 450. So actually, I'm going to include it, sorry. We are going to include the less than or equal to there at a little moment there, sorry. We want to be between 450 and 550. So we're basically going to follow the outline we have here. 450 less than or equal to 50 plus 25x, and then the higher range is 550. From here, we solve this, which is just like how we solved this one back here. I need to start by subtracting 50 from each piece. So I get 400 less than or equal to 25x less than or equal to 500. And then I divide everything by 25 to get x completely by itself. So then when I divide, I get 16 for 400 divided by 25. I get just x in the middle, which is what I want. And 520 divided by 25 is 20. So this solves the inequality, but since it's a word problem, we usually describe our answer with words. What was x representing? X was our number of deposits. So if I make anywhere between 16 and 20 deposits, I will end up in that $450 to $550 range. 16 deposits exactly will give me exactly 450. 20 deposits exactly will give me 550. Numbers in between will give me a number in between those two numbers in terms of what's in my bank account. That is it for today for compound inequalities. I hope you have a wonderful day.